just the idea of making the whole game 3D is pretty good, I think. Here it comes. Watch closely. So he fails. Yes. That's it. And that's the evil busy. Right. So far we have regexes are the sublanguage which hide exotic control flow in the form of nested for loops. That's actually one way to implement regexes. Not necessarily a good one, but it works. And the nested for loops have next instructions in them to sort of backtrack when you went the wrong way inside a regex. But the core problem here is we don't have regexes, we have grammars. And grammars are implemented as different levels calling each other. And the core problem becomes this. We're starting something finished. You already finished a level, and then you have to backtrack into that level and sort of do something else in it. And down at the level of actual subroutines, it becomes something like this. You call the sub returns the result, everyone's happy, but then you come back and say, oh, that result didn't work further down the road. Could you give me another result? And the sub just says, huh? Because subroutines don't work that way. They return and then they sort of throw away all the stack information and things they have going. So there are different traditional solutions to this. Coroutines is one. It's explicitly telling your subroutine that, okay, you're going to keep enough information to keep going from the point where you were last. You see this in Ruby's yield, for example, and you see it in Perl 6's gather. Both of these are ways to keep going from the last point where we were. We have continuations, which are sort of a generalization of this idea. It's turning the place where you were, along with all the information there, into an object and passing that object around and sort of waking the object up when you need it. We have it in schemes call CC and set jump, long jump. Right. I was going to say that these are actually gotos on steroids, but they're more like an exception mechanism. But gotos on steroids might actually give you the right kind of scary respect for them. Then we have streams, things which are potentially infinite but which generate on demand, and you can keep all the old values, so backtracking is just a matter of going back to the old values. Standard does this. That's Larry's implementation of the Parsea grammars in using a Parsea grammar, so it's sort of self-referent. They're not called streams in there, they're called cursors, but it's the same idea. Finally, there's the cheating solution, which I'm employing in my grammar engine. Simply saving what you need from the rule that finished into a custom object, and when you call that rule again, you just query the object and say, where was I? And the object tells you, well, you should set these variables to those things. It's actually the lowest common denominator of solutions, just faking it. But then there's the other core problem, which not everyone agrees is a core problem. It's all wrong. The regular expressions in Perl 5, Perl 6, and other languages aren't really regular expressions, according to some people. They are fundamentally corrupt. They do things the wrong way. The tree I showed you earlier, you shouldn't be descending into each thing sequentially. You should use a Thompson engine. Here again, I'll show you how much. Here you go. This kind of provocative paragraphs shows what we're talking about. So the regular Perl regex engine there has pathological behavior in one case, and the Thompson engine is nice and slow and rising. it's a bit controversial because some people say that, oh, this is only for pathological cases, and if you do it with Thomson engine, which I'll explain shortly, you get a constant factor which slows things down in general, and we don't want that. So the way the Thomson engine works is using proto threads. Basically, figures out from the regex you put in a state machine, which represents this regex. So inside of the tree, it has a state machine, and then it goes through this state machine with several different threads at once, with several different potential matches at once. And the only thing it keeps in lockstep is the position in the string. So first it does all the threads for the 0th position in the string, and all the new threads that were generated from the first position, second position, and so on. So it only goes through the string once, and this is widely different from doing it with sort of typical Perl or other scripting language regex engine, where you can sort of backtrack and go back. This engine never backtracks. That's it. So it has a static state machine which goes through once, but it goes through it once with many different potential options. Except there's a big but here. Something like this, which you remember contains program code here, that won't work in the Thomson engine because the Thomson engine is static. It can't adapt to new information during the run of the actual regex. So it's kind of useless for some, actually most perhaps, regular expressions. As soon as you do captures and things, you're sort of lost. At least if you use the captures in the regex afterwards, which is a problem. But it's still a good idea, I think, and it would be kind of fun to have pluggable engines. That's my long-term goal with my grammar engine, to provide at least the regular engine and the Thomson engine, and have them run the regular engine when I have to, and the Thomson engine when I can. And standard already does that, and I'm coming to that. Because standard has this view of things that you have, for every regex you have a declarative prefix, which is possible to turn into an NFA, into a state machine, and then you have, when things start to get programmatical, such as those rules in the previous slides, and then you turn back into the normal regex, and they just mesh into each other, and this is nothing that the programmer writing the regex has to think about. It just happens automatically. And the declarative prefix idea. This is two worlds meeting, and as far as I know, for the first time.
As far as I know.
As far as Larry knows, for the first time.
Meaning implicitly is the interesting thing, rather than explicitly.
Yeah.
It's a kind of lollipop.
It's a lollipop. You don't have to do anything to get this candy. And that makes me happy. Now we're at the light demo point. Been a good audience, and let me ramble on to this point, so you deserve a light demo. Can you all see this? Should I make it bigger?
Bigger.
Bigger? Yeah. That's good. Sorry? Yeah, it's sort of clumped all by itself. Right, so what do we see here? Use GG, that's my regex engine. Generally we would write grammar G, but since I'm not using so much syntactic sugar here, I'm trying to stay within ordinary POSIX. This is the closest we get to composing a grammar. It's actually fairly close. I'm happy about how similar it looks. This composes a grammar. The one main difference is, of course, that this is done at runtime, because we're not pre-compiling anything. So these regexes are built at runtime. We could change that if we wanted and pre-compile, but that would just detract from the goal. This is an example from Damien's regex grammars, where he shows backtracking and a stepwise debugger, and I'll show how his example looks. this example here, it's trying to match the string on the far left, CP file 1, file 2, and then it tries it, and it goes a bit, and then it backtracks, and then it tries some other thing. And the really nice thing about this is you don't get all this presented in one big blob of information, but you actually, it stops along the way. When it matches something more, you get to press enter or give it another instruction to step in some other way. And that's really nice. And I wanted this for Perl 6 for about a year now, since last YAPC, when Damien showed his regex grammars module. So here's the grammar running in my grammar engine. It still runs an alpha, I'm sad to say. That will change shortly. So, column rule top. And we proceed down and we do the same kinds of matchings as the regex grammars module, except with some slightly different output. My plan is to change the output to be actually identical character by character, because I like that other output. And we see a couple of successes, and then something fails. Oops, and something else fails. And then we call some other rules again, which should say backtrack here. And then things start succeeding again, and we get the ultimate match. So this is a new way to debug your Perl 6 grammars. And this is sort of the answer to the prologue light bulb joke. Instead of just saying no when something fails, now you have a chance to see how it fails. I'm basically just switching back to slideshow now. To show. Thank you. I've done a ground big refactor which found like 15 bugs or something in the ng branch. Things worked there, but it felt safer for a reason I don't remember to implement this grammar stuff and the stepwise debugger in alpha. So right now I actually have two branches of the grammar engine with different feature sets. It's not optimal. I should throw the alpha branch away. Yes? I've heard about it. How similar is it?
Not exactly the same, but it's made pretty similar, pretty quick.
That sounds nice. I should add that I started this whole grammar engine thing before NQP existed, and I sort of kept going on it because I like writing things in Perl 6, and it's fun to solve this particular problem in Perl 6 as well. But it might be that it's the easiest solution long term might be to just put this into NQP. Especially since, and I didn't linger on this point because it's kind of boring for people not more involved. There are sort of two generations of Perl 6 grammar engines. There's the group with the PGE that everybody used to use, and GGE that is basically a port of GGE. And then there's the group with standard PM and NQPRX, which do much cooler things.